All right, today we're going to do lesson 7.7, and we're going to learn how to factor special products. Now, we learned in the first half of this chapter how to FOIL or multiply special products. All right, we learned shortcuts to multiplying binomials that were special products. So if factoring is the opposite of FOILing, then today I'm going to teach you how to quickly factor special products. Does anybody remember, and if you have to look back into, I believe it was 7.3 notes, does anybody remember the two types of special products that we learned back at the beginning of this chapter? We've got the square of a binomial. All right, we have the square of a binomial. And if you remember from a few weeks ago, that looked like a binomial that had been raised to the second power. All right, what was the other special product that we learned? The difference of squares. The difference of squares. All right, and if I were to give you an example of that, it was a plus b times a minus b. Now, did either of those pop up in today's notes as you were copying them down? Did either of those special products pop up in today's notes? Difference of squares. Okay, it said the difference of two squares, but I actually went back and changed it to the difference of squares. So, what you may not realize is the square of a binomial is the same thing as the perfect square trinomial. So really, both of the special products that we learned back in 7.3 are in today's lesson. Again, factoring is the opposite of FOILing or multiplying. So that's what we're doing. We're taking these special products and I'm going to teach you how to factor them quickly. All right. Now, the essential question, how can you recognize and factor special products? The key right there, the key word right there is recognize. If you aren't getting in the habit of recognizing what a special product looks like, then obviously you're not going to try to factor with the shortcut. But just like last time, if I am taking the time to teach you the shortcut, I am going to grade you on the shortcut. I am not grading you on whether or not you can factor these with the X method. Okay? You can, at least for the trinomials. But I'm not checking for that. So pay attention and let me help you make your life easier. All right? The difference of squares. The formula says that a squared minus b squared equals a plus b times a minus b. So let's break apart the difference of squares. First of all, what's the first thing that should jump out at you? So far, we have factored what type of polynomial? Everything we factored has been a what? A trinomial. Very good. So the first thing that should jump out at you is, wait a second, this is not a trinomial, this is a binomial. All right, there are two terms. It's a binomial. Also, what kind of a problem is it? Addition, subtraction, multiplication, what kind of problem is it? Subtraction. There's only one option. You don't see this or that. This is it. The difference of squares is a squared minus b squared. Guys, what is the answer to a subtraction problem? A difference. So the difference of squares has to be a difference. It has to be a subtraction problem, right? The answer to a subtraction problem is the difference. So the difference of squares has to be a subtraction problem. So we're looking for two terms. We're looking for a subtraction problem. And then we're looking for perfect squares. Let's review what a perfect square is. If I ask you for the square root of 25, what would you tell me? 5. Is that a perfect square?
Yes.
Yes. If the square root of a number comes out to be a whole number, it is considered a perfect square. What if I ask you for the square root of 12? Does anybody know the square root of 12 off the top of their head?
No.
No, because if you put in your calculator, it's going to be some decimal answer. All right? So these terms have to be perfect squares. Somebody give me another example of a number that's a perfect square. 9. Perfect. Okay, what is the square root of 9? 3. Anybody got a different one? Okay, 49. What's the square root of 49? The square root of 49? 7. All right, very good. So those are numbers that are considered perfect squares. So it's got to be a binomial, it's got to be a subtraction problem, and each term has to be a perfect square. Now, here's how you factor it. You find the square root of each term, and the signs will be different. Look at that word again, different. If it's the difference of squares, the signs will be different. So 2 sets of parentheses, just like we've been used to. Signs will be different. You find the square root of each term, and you have the terms of your binomial. All right, now, the perfect square trinomial. This one has a little bit more details that you have to pay attention to. First of all, your first reaction when you see a trinomial is checking for the leading coefficient and going into that x factoring that we've learned the last few days. Okay, but I want to give you something else to check for. When I have a trinomial, I'm going to look at the first term and the third term. If the first term and the third term are perfect squares, I don't need to do the x method. There's a shortcut. I can factor in more than half the time. Okay, so let's look at these two possible scenarios. We either have a squared plus 2ab plus b squared, or we have a squared minus 2ab plus b squared. Now, what do you notice is the same about both of those formulas? One is a squared plus 2ab plus b squared. The other is a squared minus 2ab plus b squared. What's the same in both of them? The third term is being added. Or we could say the second sign is positive in both. Is that correct? The first sign is positive here. The first sign is negative here. But they both have a second sign that is positive. Now, that is what you are checking for. All right? In order for, once you figure out the first term and the third term are perfect squares, now you got to check that second sign. Is it positive? Because if it is, we're still going on this shortcut route. If it's not, then we're going to go on to our x factoring. Okay, so that's very important. And that note is not up there, so you need to add it. Okay, I would add some sort of a note here that says, in order for this shortcut to work, the second sign has to be positive. Okay, the second sign has to be positive. Now, I want you to notice the answer to both of these. The answer to both of these. We have a plus b raised to the second power. We have a minus b raised to the second power. So we can clearly see what's the only difference between these two answers? The signs. Okay, and where did the signs come from? Why is the first answer a plus b squared, and why is the second answer a minus b squared? Not the first term, but the first what, Luke? The first, what do we call this right here? First sign is positive. So look at the sign in the answer. It's positive. All right. Where did the negative sign come from in the answer? Here.
A negative sign.
Okay. Look at the first sign in this second formula. The first sign in the second formula is negative, and so is the answer. So let's look at what we wrote down as our steps. Find the square root of the first and the third term. Okay, that's going to be the terms of my binomial. The signs will match the first sign in the original problem. So the sign of your answer is going to match the sign in the original problem. And then, of course, we have to check the middle term. Because if our two terms don't make or create the middle term, then this is not a perfect square trinomial, and we got to go back to the beginning and do all of our x factoring. So we multiply and double to check that middle term. Let's highlight the formulas. Highlight a squared minus b squared equals a plus b times a minus b. Then come down here and highlight a squared plus 2ab plus b squared equals a plus b squared. And a squared minus 2ab plus b squared equals a minus b squared. Okay, the formulas are key. So highlight those and make sure you know the difference. Now, again, a lot of words. Let's put it into practice. All right. Example number 1 says factor the expression. Now, if I look at letter A, what is the first thing that jumps out at you? A, it's a binomial. Awesome. That is weird. We haven't seen anything like that so far. So far, we've only been factoring trinomials. So the fact that it's a binomial should make it jump out at you immediately. All right, what kind of a problem is it? Subtraction. Okay, that's the next thing I'm looking for. Is it a binomial? Is it a subtraction problem? So then it is which special product? The difference of squares. All right, everybody, what special product is it? Difference of squares. So I'm going to have 2 sets of parentheses in my answer. The signs are going to be different. It's the difference of squares. So my signs will be different. And now I just need the square root of each term. What is the square root of 100?
10.
So 10 goes in each set of parentheses. And what is the square root of m squared?
M.
So each parenthesis gets an m, and I'm done. That's how you factor the difference of squares. It's that quick. We don't have to do any x factoring. We don't have to figure out factors or signs. We literally put two sets of parentheses, one sign's plus, one sign's minus, find the square root of each term. Let's look at letter B. Now, what kind of a problem is letter B? What kind of a polynomial are we working with? A trinomial. So this is kind of back to what we've been doing for the last couple days. Next thing we check is the leading coefficient. What's the leading coefficient? 1. Okay, here's what I need you to understand. Special product or not, if the leading coefficient is not a 1, then you still have to check for GCF first. Okay, so special product or not, we are always looking at that leading coefficient, and if it's not a 1, we're checking for a GCF before we do anything. All right, so our initial reaction is this is a trinomial, the leading coefficient is 1, so let's go ahead and draw our x and factor. But wait, let's get in a new habit. Once we figure out it's a trinomial, the leading coefficient is 1, let's look at the first term and the third term. Are they perfect squares? M squared. What's the square root of m squared?
M.
What's the square root of 1?
1.
So are the first term and the third term perfect squares?
Yes.
Awesome. Let's check the second sign. Is it positive?
Mm-hmm.
So could this possibly be one of our shortcuts?
Yes.
Yes. So we're going to draw one set of parentheses and we're going to raise it to what power?
Second.
The second. Our sign is going to be, no.
Negative.
Remember, we look at the first sign in the original problem and that comes down into our answer. Now, all we have left to do is find the square root of the first term and the square root of the second term. I'm sorry, the third term. What's the square root of m squared?
M.
What's the square root of 1? 1. Now, before we box this in, we got to check. We got to make sure that those two terms give us the middle term from the original problem. So, over here to the side, we're going to do 2 times a times b. What is our a term in our answer? Remember, a is the first term, b is the, look at your, if you go back to your formulas, a is the first term, b is the second term. So what is the a term of our answer? M. And what is the b term? Careful. -1. So multiply those together. What's 2 times m? 2m. And what's 2m times -1? -2m. Was that or is that the middle term of our problem? Mm-hmm. It is. So we boxed in our answer. We're done. That is our answer. Because what's going to happen is if we go back and do all that x factoring, we figure out all of our signs, we're going to get m-1 times m-1. And then we would have to condense our answer down to m-1 squared. Okay? But I'm not checking to see that you can, I'm checking that you recognize the special product and can do the shortcut to factor it. Okay? Let's look at letter C. First of all, what jumps out at you? It's a binomial. What kind of a binomial? It's what kind of a problem? Subtraction. Now look at the leading coefficient. Look at the leading coefficient. Is it a 1? So what is the first thing we have to check for when we figure out that our leading coefficient is not a 1? A GCF. So looking at 9 and 16, is there a number that goes into both 9 and 16? There is no GCF. There's no number that goes into both 9 and 16. So we're going back to our thought process about our shortcut. All right, it's a binomial. It's a subtraction problem. So are both terms perfect squares? I don't want to hear more than one person say yes. Are both of these terms perfect squares? Yes. So we're going to have how many sets of parentheses? 2. Our signs will be, it's the difference of squares, so our signs will be different. All right? Different. All right. Talmadge, what is the first term in each set of parentheses going to be? 3 what? No, you got to square root the whole term. 3n. Very good. The square root of 9 is 3, and the square root of n squared is n. So each parenthesis gets a 3n. And then what's the square root of 16? Class, what's the square root of 16? 4. Good. So each parenthesis gets a 4. And that's our final answer. Now, it's not a horrible idea if you want to, like in your notes, to show yourself what you're doing. If you want to draw that square root symbol over In this case, the first and the third, both in the difference of squares. Okay, that's not a horrible idea, at least for your notes, so you can remember what you did to find those terms. Now, look at letter D. What kind of a polynomial are we looking at? A trinomial. Is the leading coefficient 1? Because that's what we're always checking for first. No, so if not, we're looking for a GCF. Carson, do you see a GCF on letter D? So 9, because 9 is the smallest number in our problem, and 9 goes into itself and into 36. So before we do anything, before we check for any kind of shortcut, we got to pull out that 9. All right, 9z squared divided by 9 is z squared. Bring down the plus sign. What's 36z divided by 9? 4z. Bring down the plus sign. And what's 36 divided by 9? 4. Awesome. Now, we've pulled out the GCF, so look at your new trinomial. Is the leading coefficient a 1? Awesome. So normally we go straight to that, but we're going to check for a shortcut first. All right, look at the first term, look at the third term. What do you notice about the first term and the third term? They are what? Okay, but they are what? What's the whole point of our lesson today? They are what? Perfect squares. The square root of z squared is z. The square root of 4 is 2. So this is a shortcut problem. This is a special product. This is a perfect square trinomial. So how many sets of parentheses are going to go in this answer? 1. And it's going to be raised to the power of 2. What's the sign of this one going to be? Good. Remember, we look at the first sign in the original, and that becomes the sign of our answer. So we bring down the plus sign. Now, we need the square root of z squared, and we need the square root of 4. What is the square root of z squared? Z. And what's the square root of 4? 2. Now, let's check it. Over to the side. 2 times a times b. What is the a term? Z. And what's the b term? What's 2 times z times 2? No, you're not squaring anything. It's 2 times 2 times z. 4z. Was that my middle term?
Yes.
Then this is my answer, correct? I heard a no. Why is this not my final answer? Very good. Remember the GCF. We talked about this yesterday. The GCF is part of my answer, so you cannot leave it behind. Always go back to the beginning and make sure there's nothing that needs to be pulled down. I want you to go to letter E and F, and I want you to work with the people at your table. Now, this should literally take you about 60 seconds to do both of these. So let's see how quickly you can do E and F with the people at your table. Let's look at letter E. First of all, what jumped out at you right off the bat? Binomial, and it's what kind of a problem? Subtraction. Very good. Leading coefficient? Not a 1. So was there a GCF? Did you even check? Was there a number that goes into both? Because remember, even if it's a special product, we have to pull out GCFs if possible. Okay, but there is not one for letter E. So we go straight into our answer, which was how many sets of parentheses? 2. Our signs are
Positive and negative.
Positive and negative. All right. What is the square root of 16h squared?
4h.
4h. So each parenthesis gets a 4h. And what is the square root of 49? 7. So 4h plus 7, 4h minus 7. Raise of hands. How many got that one right? Okay, awesome. Letter D. It was a what? Trinomial. The leading coefficient was 1. Did anybody try to X factor it?
No.
Okay, good, because our next step is now to check the first term and the third term. Were they perfect squares?
Yes.
Yes. Did you check the second sign?
Yes.
Is it the right kind of sign?
Yes.
Yes. So how many sets of parentheses does this answer have?
1.
And it's raised to
Second.
power. All right. What is the sign? Jamara, what's the sign of my answer going to be? Good. The first sign in the original problem is negative, so my answer will have a negative sign. And Jamara, what's the first term? D, because the square root of d squared is d, and the second term. Huh? Well, what's the square root of 25? We find the square root of the third term, which is 5. Now, we got to check that middle term. We cannot box this in until we're sure. Tristan, what is the A term? And what is the B term? Careful. -5. All right, so when you combine those or multiply those, you get what? Was that our middle term? Then that is our answer. Awesome. How many of you got D minus 5 squared? Okay, very good. Just don't forget to check the middle term, make sure it works. Because if for whatever reason your answer does not make the middle term, then you've either done something wrong or this isn't a special product. You have to go back to the X method. Now, in example 2, you're asked to solve the equation. Nothing changes from any other day that we have learned to do this. Okay, we must do what first before we can solve the equation? We must do what first? Before we can solve the equation, we have to factor them. So let's look at letter A. What kind of a trinomial are we having to factor? I just said the answer. What kind of polynomial are we having to factor? Trinomial. Okay. Is everything on one side set equal to 0? All right. So we can go right into factoring. Now, the leading coefficient is a what? A 1. So this might be your initial reaction, but we now have a shortcut to look for. So we look at the first term, we look at the third term. Are they perfect squares? Look at that. Don't let that fraction freak you out. Okay, look at the numerator. Is 49 a perfect square? Yes. Is 36 a perfect square? Yes. Then is the fraction a perfect square? Yes. Yes, all right. So the shortcut will work. How many sets of parentheses? 2. Oh, and the shortcut works because the second sign is positive. So we're still in good shape. Now, the sign of my answer is going to be what? Good. The first sign in the problem is negative, so my answer will also be negative. What is the square root of w squared? And what is the square root of 49 over 36? Good. The square root of 49 is 7 over the square root of 36, which is 6. Now, we still got to check our answer. So let's check 2 times A. What's our A term? And what's our B term? Careful. -7/6. And when we put that in the calculator, it actually does all of the multiplying and the reducing for us. So what does that give us? -7/3 W. Good. Is that our middle term? Yeah, it is. Now we bring down what we have not used, which is the equal 0. How many equations are we going to have to set up and solve?
1.
Very good. Why just 1? Why not 2? Okay, if the binomial is raised to the second power, if I write 2 equations, I'm writing the exact same equation twice, so that's not necessary. So we bring down w minus 7/6 equals 0, and how do we solve for w? We add. Okay, we don't panic because it's a fraction. We just add 7/6 to both sides, and w equals 7/6. Great job. Any questions? All right, let's look at letter B. Is everything on one side set equal to 0? All right, so we're good. What jumps out at you about this problem that we are supposed to be factoring? It's a binomial, and it is what kind of a problem?
Perfect.
Subtraction. Okay, we've got to check. Is it a binomial? Is it a subtraction? Because if I give you this right here, the shortcut doesn't work. N squared plus 81 does not work. So is it a binomial? Is it a subtraction problem? All right. Leading coefficient? Good. So we don't have to look for a GCF. We can go straight into factoring with our shortcut. How many sets of parentheses?
2.
The signs will be different. And the terms will be n and 9. Very good. The square root of n squared is n. The square root of 81 is 9. And we bring down the equal 0. Now, how many equations do we have this time to solve? 2. The first one is n plus 9 equals 0. The second one is n minus 9 equals 0. How do I solve for n the first time? Subtract 9 from both sides. So n equals -9. How do I solve for n in the second equation? Add 9. So n equals +9. And that is our final answer. This isn't a word problem, so we keep both of our answers. We don't have to label anything, but that is lesson 7.7.